Welcome to this overview of Lesson 5. I'm Kevin Keel, OpenSciEd teacher and facilitator. So we left the last lesson with kind of a cliffhanger. We're going to solve that in this lesson. In the last lesson, students figured out that larger vibrations with greater amplitude are producing louder sounds. But what about sounds of different pitch? How do the vibrations from a sound source compare for higher versus lower pitch sounds? And we're going to figure that out in this lesson by using the same tools that we used in our last lesson, the meter stick motion detector apparatus and the computer simulation. So this is an investigation lesson. It's going to take a day, about 15 minutes of prep. There's both a student investigation and a teacher demonstration. It does not require students to use their devices. And there's two videos, one of the music box, if you don't have a music box available in the classroom, and then another one showing the how to set up the computer software for the motion detector, but it's the same as the last lesson, so that's probably unnecessary. There's two different chunks or components to this lesson. To start off, students are going to navigate in by thinking about musical instruments and how they're producing sounds of different pitch. They notice that shorter length bars in the music box are producing the higher pitch sound, and longer length bars are producing the lower pitch sound. So then in part two, we think about how we could adjust the stick in our motion detector meter stick apparatus to represent that. So we'll change the distance, the length of our stick in the apparatus, collect data from that. We'll also collect data from the computer simulation that we used in the previous lesson. The second chunk of the lesson, we're analyzing that data first individually, then we're sharing out as a class and adding what we figured out to our progress tracker. And what we're figuring out is that sound sources that produce higher pitch notes are vibrating more frequently. And then sound sources that produce lower pitch notes are vibrating less frequently. To close the lesson, there's a good formative assessment opportunity that helps gauge student understanding not only from the concepts in this lesson, but also the previous lesson. So what we're figuring out in this lesson is that pitch is determined by frequency. Higher frequency vibrations produce higher pitch sounds. Some parts I want to highlight. First, part two, where you're gathering data from both the stick apparatus and the computer simulation. So you're going to provide students with the pitch graph handout where they're going to record their data. Introduce the two conditions. A longer meter stick is going to represent a vibration that's going to produce a lower pitch sound, and then just slide the meter stick in, shorten it, and that's going to represent in condition 2 a vibration that's going to produce a higher pitch sound. And then you're going to collect data from those two conditions, similar to the last lesson, so students are familiar with the process. It goes pretty smooth. Record that on the graphs. You're also going to have students collect data from the computer simulation. It's a different simulation than we used in the last lesson. This one's called Hitting the High Notes. It allows you to adjust the pitch. So you'll play a low pitch and a high pitch sound, have students record the graph that gets produced from each of those. Then in part three, we're just analyzing patterns we noticed from the data we collected. Project all 4 graphs together. Have students compare the graphs individually using what I see statements. And then have them calculate frequency and amplitude for each of the graphs. You'll have to walk through one graph together as a class, but then they can individually complete the calculations for the remaining graphs. So we figured out a ton in the last couple lessons about how different vibrations can produce different volume sounds or different pitch sounds. And in the next lesson, we're going to use graphs of the position of sound sources that are vibrating to argue for which sounds are being made, whether they're loud or quiet sounds or high pitch or low pitch sounds, just based on the graphs. And then we're going to take all the things that we figured out, revise our initial class model, and return to our driving question board and take stock of which questions we've answered already. Just a few things I found successful in my classroom teaching this lesson. First, allow the students to play with the music boxes in small groups if they have the opportunity to. You can get a lot of mileage out of these little music boxes. Kids love playing with them. It does a great job of highlighting for them the idea that longer bars lead to lower pitches and vice versa. Next, the pitch simulation in part 2. I would set the time scale on the bottom at 0.1 seconds, allow students to see the graph a little bit more clearly. If the pitch is set too low, no one will be able to hear the sound. If it's too high, kids will complain that it hurts their ears. So just a heads up on that. Part 3, when you're generating the graphs, I would do that prior to class. That's a lot of graphs to put together into one display. I would generate and arrange those prior to the lesson. And then in part 4, here's where I add to the characteristic of waves poster, which we started in the previous lesson. Here's where I add frequency and pitch to it. So I would recommend doing that at that time, and then adding frequency to the word wall at this time as well. And then the exit ticket part 6, if you run out of time in the day, I've done it before with the next day's lesson, and it works great. In the teacher's edition, the only word they have you add to the word wall is pitch during the navigation in part 1. But like I said, I also add the word frequency during the class consensus discussion. Again, here's where I add in this lesson to the characteristics of waves poster. And you're not going to use that in future lessons, but it's a good way to capture all the things we've investigated in the last couple lessons, and might be helpful to refer back to in lesson 6 as well. So that's it for lesson 5. We put together a lot of stuff in the last couple of lessons about how vibrations can produce sounds of different volume and different pitch. In the next lesson, we're going to take all those pieces, put them together, and complete our first summative assessment. See you then.